Happy Valentine's Day, everyone. We should give an award for the best Valentine plan. Mostly because I need one. It's a pleasure for me to welcome you all here to the IGHS Grand Rounds. We have a distinguished speaker here today, but we're going to Dr. Quartz, Teresa Quartz, who leads the affiliate program, faculty affiliate program for IGHS, is going to make the introductions. Dr. Quartz.
Thank you. Hi. Thanks so much, everyone, for coming. Nice to see you. So as George mentioned, I am the affiliate program director. Just to give you a little bit of overview on what that is, we kind of organize and help connect the rest of the university with the great work that IGHS is doing in global health. So we have more than 360 faculty and staff who are outside of IGHS who are doing really great work. And we focus on the network and community building across UCSF and global health space. It's open to anyone who is faculty or staff. You can go to the new website to apply. And it has perks, so not only the networking and social events, but also the ability to apply for SEED awards as well as early investigator awards. So check it out. But today I actually have the distinct honor and pleasure of introducing a friend and colleague of mine, Dr. Gama Bandawe. We've been working together now since 2015, maybe even. It's been a while. And so it's really a personal pleasure of mine to have him here to give grand rounds. So Dr. Gama Bandawe, he's from Malawi and the University of University of Sciences, aka MUST. So if you hear us talking about MUST, that's what it is. He is a medical virologist and a senior lecturer at MUST. He earned his doctorate degree from the University of Cape Town in South Africa and studied HIV, specifically viral diversity and humoral immune response, in order to inform vaccine development. He then returned to MUST to serve as the very first head of the Department of Biological Sciences, and he's currently here at UCSF with us as a Fogarty GloCal Fellow. He's studying non-malarial fever in Malawian children with Dr. Annika Hooft, who's sitting over there. And they're using metagenomic next-generation sequencing techniques to identify pathogens, and they partnered with the Chan Zuckerberg Biohub to do that. So it's really a personal pleasure of mine to welcome Dr. Gama Bandawe. So please take a look.
Right, thanks very much for that very kind introduction. And I just want to say it's a real pleasure to be here and share the story of MUST with you all. Okay. Okay. Okay, that'll work for the space bar. Works fine. Okay, great. This is what my talk's going to look like. I'm going to tell you a little bit about Malawi. I feel that I'm here as a bit of an ambassador, so I'm going to give you a bit of context on that, give you a bit of context on the health situation, the education situation, then talk about MUST. And I really want to provoke some ideas and thoughts and maybe some collaborations as well. Talk about the background, what we're doing at the Academy of Medical Sciences, and then talk about the research infrastructure and some of the work that we've done, and then just end off with explaining a little bit about the projects that we're doing. And of course, my emphasis is on the partnership that has been in existence between us. And as Teresa mentioned, we've been working together in some form of partnership since 2015, and I really want to share a little bit about that. So Malawi, some of you might not be aware about where it is. It's in, let's move that. Thank you. Malawi is right in between. We are part of the Southern Africa region. We're also part of the East Africa region. We like to call ourselves the warm heart of Africa. It's a very small country, 20 million, very young population, split into 3 regions, 28 districts, and with Chichewa as the national language, and English is also official language. Okay. Let's see. Okay, so we're very proud of our country, lots of heritage, lots of culture, lots of wildlife, heritage both natural and otherwise. We have one of the most biodiverse lakes you might have heard of. It's one of the Great Lakes in the Rift Valley region. But of course, Malawi is not without its challenges. And if you look at the health context, I'll give you just a few key indicators. A small population of about 20 million, but more than 60% of people live below the poverty line. So obviously that's a big issue. Total government expenditure on health is very high. It's about 16.8%. The OECD average is about 6.3%. So we have a situation where we are spending a lot more on health than we actually should be. And of course, you can see some of those other indicators. The density of physicians per 1,000 population is really low. Nurses and midwives, better, but still unacceptably low. And then unacceptably high neonatal mortality. And that's obviously an issue. There have been significant improvements, but it remains a big challenge, which we continue to want to address. And then, of course, I think for all of you living in California, the reality of climate change is all too real. With natural disasters, wildfires, and all of that. Last year, about 11 months ago, we had a tropical storm that started in a whole other region of the world, in the Australasian part of the world, named Freddy. And this came all the way across, tracked the equator, and came all the way across the Indian Ocean. And to a point, it became the world's longest lived tropical storm. And in fact, it's on record as the second most energetic tropical storm ever recorded in history. And that came and lingered around Madagascar, went inland and came back, and then went and just hovered over southern Malawi and caused some serious devastation. So, problems on top of problems. I don't need to explain that the health situation was already bad, but it caused a huge cholera outbreak. In fact, we're still recovering from a cholera outbreak from the year before, and this, just exacerbated the situation. What's interesting with climate change is that there's some very direct things that happen, but and for those of you studying global health, this is really important to understand that there are some very sort of secondary things that happen with climate change. So, for example, the flooding that happened in Pakistan led to a huge cholera outbreak in Malawi. So when we eventually came around to sequencing the cholera strain that was circulating in Malawi, it turned out to be an import from Pakistan, and a lot of the movement out of Pakistan happened because of these floods. So there are these sort of knock-on effects of climate change, and they have huge implications on health. Just to give you another statistic, Malawi is also second to only Eswatini in terms of cervical cancer incidence as well as deaths. So we have a lot of serious issues. Okay, now, because I'm in the education sector as well, usually globally about 13% of the population has access to post-secondary education. The US does really well. It's way up there, about 39%. If you look regionally, Malawi, with a population of 20 million, has about 114,000 university graduates, which is incredibly low, even at a regional level. South Africa has 8%, and for us, that figure basically translates to about just over half of 1%, which is really makes it very, very difficult to develop a country and to generate the expertise that's needed to lift us out of poverty. So that's a big issue. So at MUST, we are trying to address both of these issues. You'll see that these are figures from 2013, Malawi is over there. A large share of our students had to actually go abroad to access tertiary education. But it's something that we recognize, and you'll also see Malawi stand out there because it, in addition to spending large amounts on health, Malawi also spends large amounts on trying to educate its population. So these are things, at least at the political level, we've figured out and are working very hard. And of course, MUST, as I'll tell you just now, opened its doors in 2014. And you'll see that we've made some significant inroads in terms of increasing access to education. There are a few other things that happened, during that time, but from about 2015, you can see the absolute spike that has happened, and I'm very proud that MUST is an important and significant part of that. If you look at the amount of money that we're spending in education, you can see that since about 2010, when we try to turn things around, we've been trying very hard to increase. And it's been a matter of dealing with other competing priorities and other things. You can see that graph is trying really hard to go up. But there have been other challenges. The tropical cyclones and other things have meant that money has had to be diverted elsewhere. And I'm saying all of this just to really provoke you to think about the per capita impact that you'd have when you partner with an institution like MUST and do work in a place like Malawi. Okay, so let's talk about MUST, which is the Malawi University of Science and Technology. MUST was built from around 2010, and it came as a government-to-government loan and grant, in part, from the People's Republic of China, for those interested in the geopolitics of that, who were one of the few countries that recognized Taiwan and switched, and it was one of those things that happened. So we were established as an act of parliament in 2012. And the first enrollment happened in 2014, and with a very small cohort of about 130 students initially. It's a beautiful campus. I want to invite you all to please come and see. It's in the rolling hills of southern Malawi in Cholo district. Really well constructed, really nice infrastructure, and really a pleasant place to work, and it's a real privilege to work there. And it is, of course, a once-in-a-lifetime opportunity to be in a place like that from the ground up, right at the beginning. We have 4 schools. We have MIT, the real MIT, which has computer courses. All of the engineering programs are also in there. We have a School of Climate and Earth Sciences that has some really interesting and exciting programs, including disaster risk management, sustainable energy systems, water quality, and other things like that. This also hosts a Drone and Data Academy, which I think many of you would be very interested to learn about how we use that technology in healthcare and disaster management and all sorts of other things. We have a School of Culture and Heritage, which I think is something you'll all appreciate, that even the best medical intervention will completely fall flat if you haven't got the social science side of it and the anthropological side of it. And we have a really exciting program called Indigenous Knowledge Systems and Practices. We are doing things like ceramics in our quest to try and industrialize, and a really excellent program. And then, of course, we have the Academy of Medical Sciences, where I am. And our programs that we have at the moment are in medical microbiology and immunology, in medical imaging, and we also have a sports science program, just recognizing, having lived through Super Bowl Sunday, that sports is $1 trillion industry, and we want to be able to try and contribute to that as well. So, when we're establishing programs, we were very deliberate about making sure that we try to establish programs that specifically address areas where other institutions haven't been able to develop expertise or where there are gaps. We felt that there was a need for medical microbiologists and immunologists to be trained at an undergraduate level. I think many of you will know that if you know of any immunologists, most of them did something completely different. They were medical doctors or chemists or something else before they went into immunology. We decided to train immunologists from an undergraduate level. We established the Biological Sciences Department in 2016, which later became the main department of the Academy of Medical Sciences, and we enrolled our first cohort, our first medical microbiology students in 2016, and we started the immunology program as well in 2018. And we developed these curricula from scratch. And I'm very glad to let you know that this year, in 2023, we enrolled our very first master's students in both the medical microbiology as well as the infection and immunity or the immunology program as well. And we're in the process of screening to enroll the second cohort as well. And the first cohort, it's a 2-year program. They do a year of coursework, and then they do a year of a research project as well. So we're getting started on those projects as well. The research infrastructure didn't exist. I'm going to take you back here. Beautiful college, but it's really perfect as an arts college. It didn't have specific custom-built spaces for science and technology, and that's a challenge that we had to confront and take on. And so we had to build the research infrastructure. The first thing that we needed to do was to hijack some of the classrooms and repurpose those into laboratories. Not an easy thing to do. But with our Vice Chancellor leading the charge, we managed to get that done. And so we set up some labs, both for teaching as well as for research purposes. And then with all our money spent, we had the challenge of now trying to equip those labs. I want to give a big shout to our partners who are based in Boston. This is Melissa Wu. She's the CEO of a nonprofit called Seeding Labs. And what they do is that they partner with institutions from low and middle income countries who do not have access to basic laboratory equipment. And they have a program called Instrumental Access, and they basically shipped us a container full of basic laboratory equipment. That was back in 2018, I think. So that really went a long way to setting us up, biosafety cabinets and -80 freezers and all sorts of things. And this really allowed us, when COVID came around, to be really well positioned to contribute to the response to that. I'm sure you can remember all the panic that ensued around there. But then it also meant that we could give our microbiology and our immunology students some real practical training. And when COVID came around, Seeding Labs didn't drop us. They continued to support us with some funding and with some equipment as well. And we've been able, through our partnerships with Dr. Anker, which I'll talk about, to bring on some more equipment as well. We are now in the process of building a purpose-built lab complex, which will open, I think, towards the end of, in 2025, end of this year or sometime in 2025, which I'm very excited about, which means that we'll be able to, install specialized equipment and partner again with Seeding Labs, who are going to help us with installing specialized equipment in there. The research infrastructure also needs research support services. One of the most important things is to have an IRB. Until Musk decided to change the game, then there was only one IRB in the country, or there was the overall mother IRB with the National Commission for Science and Technology, and there was COMREC, which was from another public institution. We became the second IRB to be established outside of the NHSRC, so COMREC and MUSTREC basically. And I'm very happy to say that, when someone shows it's possible, a lot of things happen. So it led to an explosion of other recs that have sprung up. So University of Malawi, Mzuzu University, Catholic University have all since sparked their own, initiated their own research ethics committees. And it was our director of research as well as our MUSTREC administrator who led the charge. And I'm very happy to say that we are now registered with the US Office of Human Research Protection, and we have an IRB number. And so that was a really important and significant step. There are other really important research support services that need to be established that we are continuing to work on. And so if any of you have expertise in those areas, these are some of the things that we're really thinking about. With wanting to strengthen grant writing skills, research mentorship of faculty and future research leaders. I think that's a really important aspect. It's one thing being a researcher, it's another thing being a research leader and being able to mentor people. I think that's really important. We want to strengthen our grants management capacity as well. There's some challenges that we've been having. And I think that we really need to move forward in that. And one of the things that we're looking at is applying for an NIH grant that will help us with that. It's the G11 grant that seems specifically catered at building capacity for enhanced research administration, especially in Africa. And so if anybody has had any experience with that sort of thing or would like to help out with that, I think that would really make a huge impact in our ability to conduct research moving forward. All right, let me talk about these studies on febrile illness and where the partnership with UCSF really began. Okay, let me try and clear this. Yeah. Okay, so the story really began with, I think, a friendship between these the two ladies at the top over there, Professor Adres Malata, who's our Vice Chancellor, and her friend, Professor Emeritus at UCSF, Sally Rankin, who was doing some really incredible work with mobile clinics in Malawi with Global AIDS Interfaith Alliance. And they were really, they had some mobile clinics and were going out into really far-flung and hard-to-reach areas of the country and making a huge impact. Alongside came another one of my mentors, Kim Baltzal, who was looking at the issue of these non-malarial fevers, and in partnership with my great mentor who's here right now, Teresa, and they did I remember partnering with them initially. I had a very small role to play in this project, but I remember that very initial work that they did looking at all of these the fevers. And you see, in Malawi is malaria endemic. And the assumption is when a kid comes in with fever that it's malaria, and that's often not the case. And when malaria is ruled out, what happens afterwards is really a challenge in many regards. And Kim and Teresa went ahead and looked at this, looked at follow-up at the mobile clinics, looked at some of those other risk factors, tried to figure out how you can determine which kids are at risk. And we looked at things like biomarkers to try and distinguish, try and pick out what's happening with these non-malaria fevers, looking at the issue of sepsis as well. And this was some really interesting work. And, it was really a pleasure to see the work that they were doing. And it's something that really excited me as a virus person. And I thought it would be really interesting and exciting to partner with them and to continue to build on this incredible work that they've been doing. And so at the suggestion of both of my mentors, Kim and Teresa, the GloCal Fellowship came up and we were able to apply, managed to get it a second time of trying. Just a big shout out to the director, Craig, and Kimberly, who's here and does an incredible job pulling this all together. It's a year-long fellowship program, and mine is running from July of 2023. It's going to end at the end of June in 2024. And this program is really focused on mentorship and training, and it includes a research project that needs to be done during the course of that 1 year period. And within there needs to be a 3-month US-based mentorship and training program. And this is what has brought me here. So I'm here for just under 3 months, being hosted by both UCSF and the Rapid Response Team at the Chan Zuckerberg Biohub. And the major aim of the whole fellowship really is built around establishing metagenomic sequencing capacity at MUST. We'll try and see if we can get some publications out. And the other thing that this great program does is that it puts you on that research track to be able to try and access NIH funding, which I think is really such an important thing for trying to develop research capacity in a place like Malawi. My mentors have a local mentor, Professor Sam Piri, who's at Partners in Hope, and of course I have Teresa as my mentor, and Christina Tato is Director of the Rapid Response across the road at the Chan Zuckerberg Biohub, and I'm doing my training with her team, who've really welcomed me, and I've learned so much in the last few weeks. It's great to be part of this amazing team. So the GloCal Fellowship, the project aims essentially are, we hypothesize that there's these febrile illnesses, that there's a huge range of pathogens that are causing these, and that metagenomics would be a great way to try and study that. So essentially, we want to set up a cohort to study that. I want to learn metagenomics, establish it, and then look at these febrile illnesses in Malawi using these techniques. And as a virus hunter of sorts, I want to explore the taxonomy and viral diversity of pediatrics. Now, alongside that is my co-investigator, partner, Dr. Annika Hooft, who's with UCSF, and we set up the Malawi Pediatric Temperature and Microbiology Observation Study, or the DAMBO study. There she is. With a bit of funding from some UCSF sources, and she did some really great work to get money from the resource allocation program as well. And essentially, we're looking at this same issue of fevers and the management, diagnosis and management of these fevers once you have ruled out malaria. And the integrated management for childhood illness, those pathways are great, but they're not perfect in our setting. And we really wanted to look at how we can improve these. How to figure out what's a bacterial infection, what's a true infection, what are the viral infections and other things. And the whole aim is to be better at predicting the real risk. Which kids are going to be really sick, which kids need to be attended to in either an ICU or HDU. And if the sooner you know that, the sooner you'll be able to really address whatever issues might be going on there. And so we're setting up a longitudinal study. We plan to recruit about 800 children in Chola District Hospital. It's a rural tea-growing area. And of course, we're looking for malaria-negative kids under 5. And we're recruiting both from OPD and emergency with a guardian who can consent. And then there will be some testing that will happen. Each child will have a sterile blood draw, and we're going to look at blood culture and some biomarkers as well. And children with respiratory symptoms will then be put into the other arm of the study, which is the one that is directly under the GloCal study that I'm doing over here. And so those samples will be partially processed in the Chola lab and then shipped over to MUST, where we'll do blood cultures and biomarkers and hopefully report those results back. There will be a little bit of follow-up as well, where admitted patients will be followed up with a phone call 2 weeks later so that we can look at the outcomes as well and see if those can factor into these prediction models that we're going to be looking at. And so we want to evaluate how well the different risk factors predict illness and compare both the clinical factors with the biomarker tests and have some sort of model. And then, of course, from my perspective, we'll be using metagenomics to try and figure out what's going on. Those who have respiratory symptoms, I'll be looking at metagenomic sequencing to really understand what's going on in terms of respiratory viral illnesses. And that is what this project is, the Bira project, where I'll be looking at the metagenomics for pathogen investigation in respiratory elements. The rationale is basically the same. And where these studies have been done elsewhere, essentially we find that there's a huge diversity of illnesses or etiological agents that are associated with non-malarial fevers. And metagenomics is really an excellent way to take a look at that. There's a huge number of bacterial causes, a huge number of viral causes. And when the Joe DeRisi lab over here did an analysis, they found some really interesting stuff especially in terms of viruses, including one virus which hadn't been described before. And that is essentially what eventually we want to look at, of course, starting just with the respiratory viruses for now. But I believe that there's a whole diversity of viruses out there that we really don't understand what's going on. And so I'll have 2 study sites, including the one in Lilongwe as well. And that's essentially what we're going to be doing. We expect that we'll have slightly fewer of those. Not everybody presenting a fever has respiratory symptoms, but we'll also get some healthy controls to match and analyze those. Some protocol training, and that's Annika over there. And so we are actually in the course of piloting right now, and getting through those initial teething problems. I was just saying to Annika that I have a lot of respect for all of you who set up clinical studies. There are a lot of issues to deal with, and it's very easy to look at a paper and say, you know, N is 1,000. Getting to that 1,000 is no joke. And so we're training them in ethics as well, and really setting up a clinical research team. My mentorship and training program is going on really well here, and I'm picking up the metagenomics. I just want to give a shout out to Teresa as well, who is actually in the lab with me the last couple of weeks, showing me a few tricks as well, and just the rapid response team from the Chan Zuckerberg Biohub that's done an incredible job. I want to just end by talking about a couple of things, some knock-on effects. The establishment of metagenomics capacity at MUST will allow us to do a lot of virus discovery and also pandemic preparedness. And there are at least 5 other projects that are going on right now that will benefit from this. And I'll just quickly run through them and mention those before we have a discussion. With Dr. Annika Hooft, we are looking at the Malawi surveillance program, which is part funded by the UCSF Center for Pandemic Preparedness. I'm looking at a rodent virus survey, a snake filovirus survey, and we're also looking at isolating bacteriophages for antimicrobial resistant bacteria as well. With the Malawi Surveillance Network project, essentially healthcare in Malawi, not everybody can access a hospital, right? So you have hospitals, some people only access their healthcare through drug shops and pharmacies, and then there are herbalists and traditional healers, where about 80% of Malawians is their primary form of healthcare that they access. And so in that context, if an outbreak should happen, it'll be a while before it's picked up by the formal system. And we want to figure out how we can better create a system that will detect these outbreaks early. And so the project essentially just aims at using qualitative methods to describe and map the network of traditional healers and their practices of other practitioners of formal healthcare around Cholo district, and to identify those who have the capacity to function as sort of sentinel surveillance sites, who are willing to cooperate with us and would understand how important it is if they see an ailment that they just haven't seen before, to let someone else know. And then we want to actually establish that pipeline to say, what would the mechanics be? How would that work if someone is identified? And of course, because we're trying to identify what could potentially be a novel pathogen, metagenomics has a role to play in that as well. The second issue is this rodent survey. There's a very short story here. In about 2011, there was a hemorrhagic fever, a small hemorrhagic fever outbreak that happened just across the border from us in Zambia, where a lady was taken ill. She was medevaced to South Africa. I think there were 5 people that were involved in her medevac. 4 of those passed away, including the index case. They had to name it was a new arenavirus, they had to give it a new name. Lusaka, and Joburg, where the first casualties of this were. And then the virus quietly disappeared. Okay, and there's been a lot of work since then to try and find out where this virus came from, but they've just found a whole bunch of other viruses and no one really knows. Okay, so this thing is lurking somewhere. Now in Malawi, we have a tradition of eating or consuming field mice as an important source of protein. There are over 40 species that are consumed, and these are mainly wild varieties. That's a mouse kebab. The synanthropic species, like rats, are generally not consumed. We find that that they're quite different. It's offensive to suggest to consume rats. Hunting and trapping is a cultural practice, and it's done quite widely. But we don't know what potential viruses could be, lurking within these species and could be potentially passed on in some sort of zoonotic event. So I'm conducting a virome survey to try and capture as many rodents as I can and to try and take a look. And the metagenomic sequencing, the access to the CZID pipeline that I'm being trained on right now is a big part of that. And some of the data that we have processed, or that we'd already generated but were unable to process, is something that we'll be looking at. Then I just want to mention also, this is totally inspired by Joe DeRisi at the Biohub. So he's done great work on snake viruses and snake virus cell lines, and suggests that snakes harbor at least definitely arenaviruses as well as potentially filoviruses and other viruses with pandemic potential. We're particularly interested in pythons and boas, and we've partnered with a great organization called African Parks that has a concession to run these protected areas in Malawi. And metagenomics is going to be a big part of that. We are sampling already. You can see that's a small python that we've caught, and we are trying to trap much bigger snakes. You'll see this is actually from this weekend, the trap that's being dug there. So we're going to see what comes of that. And then we are also looking at bacteriophages. There's a huge pandemic of antimicrobial resistance. The pipeline of new drugs, is something that we can't really bank on. It's great that there's a new class of antimicrobials discovered in the last couple of months, but we know that it's going to continue to be a problem. And so we've been screening and looking for bacteriophages from various sources, including wastewater. We've partnered with somebody from out in Poland, a Malawian student out in Poland who's a bioinformatician, and he's done a few analyses, and we've identified over 580 phages, and we're looking at trying to focus on the WHO antimicrobial resistance priority pathogens for that. And these are some of the analyses with the priority pathogens. And my undergraduate students actually have already been able to isolate bacteriophages from wastewater at Cholo District Hospital for strep pneumoniae, which is one of the 5 WHO priority pathogens and a known problem at Cholo District Hospital. And so I'm very proud of these young ladies who have done a really great job. But this is just a snapshot of some of the impact that this training and this partnership will have. I just want to quickly acknowledge all of these people who have some way contributed. I'm sure there's a bunch of others who maybe I've left out, but I want to thank you also for the opportunity to share some of the story with you, and look forward to having some discussions afterwards. Thank you very much.
Thank you very much. Would you mind taking a seat? We'll have about 10 minutes for questions. And then we also have one of our global sciences master students, so Tony Shirasi is here, and she's going to be leading the discussion session.
We'll first open it up to anyone who has questions. I'm also monitoring the Zoom. The microphone.
Thank you very much for that really fascinating discussion, and thank you for the work you do. It's clear you are on the cutting edge on multiple fronts, but it's gratifying to see your engagement and your persistence with it. So thank you for that. Could you give us a feel for how your effort at MUST and in general is connected to the delivery system that the Ministry of Health has scaled? Is there any relationship to the public health institutes that AUCDC has stood up? There's a lot of potential duplication of activity capability that you guys are not going to be part of, and I'm just curious what your dialogue is.
Okay, thank you. And I think that's a really great question. And something that's really important for us to be thinking about before and as we do the different things that we do. MUST is a public institution, so we are part of government, and I think for me there were a few opportunities to go outside of that system, but I thought it was really important that the public health system should have some of this capacity, and that we should build that capacity. And so our linkages with the public health system are twofold. First is that all the work that we do comes under the district health office. So we are under, all of our activities under the Chola District Health Office. So we make sure that in whatever we're doing, we're working in consult and under the guidance of the local district health authority. And so when we are setting up our projects and when we're doing whatever we're doing, we're definitely working together in that regard. And in addition to that, all of the things that we're doing, we work in partnership with the National Public Health Laboratory, which is based in a different part of the country altogether. But we work very closely with them and under their guidance. So we're informed by the same health priorities, the same national health research agenda, and we inform each other. So in fact, one of the first things that I'll be doing once I return is to pay a visit to the National Health Reference Labs, who are very aware of all the training that I'm doing here. They already have some capacity in next generation sequencing and would like to add that component. So that's one of the first things.
The whole idea.
And then we view ourselves very much as part of that whole system, in that the students that we're producing primarily are to go and enter that health system. And so at MUST, we have a system where there are a couple of things. We're very big on entrepreneurship, and so every student that passes through has to do an entrepreneurship course. But we also have a system of work integrated learning attachment to the work. And what we do is in their final year, every medical microbiology student has to go and spend a whole semester in one of the public health institutions. And so they essentially become part of that team. And when they graduate having actually spent, sat in meetings and run and coordinated and worked as part of the actual local health system. And so we've tried as hard as we can to really align that. And I think that's a really important point that, we're part of that system.
And can I ask you guys to introduce yourselves before you ask questions? So Michelle, you're next.
Eric Gooseby, I'm a professor of medicine here at UCSF. Thanks.
Michelle Shang, associate professor in PhD in pediatrics. Thanks for your talk, and echoing Dr. Gooseby's comments, just congrats and thank you for the work that you do. It's really inspiring. I just had two questions. One was around, can you talk a little bit about faculty recruitment and support for career development, what that's been like at a new university, and then just on the project looking at biomarkers or other factors associated with the development of severe disease. Like, why did you need a sample size of 800? It seems so big. And is it because you expect few severe illness? And if so, why didn't you just do like a case control design? Yeah, thanks. Okay.
Okay, thank you for that. Sorry, you're just going to remind me of the first question? Faculty, all right. Yes. How does faculty recruitment and other things work? Right? With difficulty. It's been a huge challenge. It's been a very huge challenge. I think in two regards, finding the required expertise. And then when that expertise is available, it's very competitive as well. It's very difficult to recruit and to retain these very specialized skill sets. Of course, there's the benefit of being somewhat, the new institution, and people come along. And I think our leadership has worked very hard to make our salaries very competitive. But I think it's definitely going to remain a challenge. And so, I'm not sure what else I can say beyond that, except to say that it is a huge challenge. And, for anybody who's, for those who are leading the school, I think that's a significant proportion of the meetings are spent discussing those particular issues. Okay, I'm gonna throw.
I have to go to work. I'll see you later. I have a shift today.
Annika hosted the co-PI on the study.
Yeah, I'm Annika. I'm an assistant professor here in emergency medicine and pediatrics. So I think, and those are great questions. I think like our goal in this study is not necessarily to characterize severe febrile illness. Our goal is to just characterize febrile illness in general, and really we don't even know the epidemiology of that in this setting, just because we don't have data to use. Like the records are primarily paper. It's actually like transient, like people have a book that they carry around. I mean, some of the people in this room have probably worked in similar settings. Like there's no EHR that we can go to like mine data. There's minimal testing available. So our goal was to characterize kids with acute fever and see what even happens to them, and then also just get some basic data. So we're not doing a lot of invasive testing, but this setting doesn't have microbiology capacity right now, and so we're adding that. So we, at minimum, are doing at least a blood culture, because the main thing people bring up when they treat kids with antibiotics when they're malaria negative is that they don't know, like, could they have bacteremia? Like that's always like one of the highest things that people mark down as far as like what they think the cause of illness is like, this like sepsis or kind of undifferentiated infection. And so we're just trying to see, is that fear real? Because they don't know. I mean, there hasn't been testing available, or is it more likely that there's, lots of viruses and other things that are causing this? And then how do we help them figure that out? So the main biomarker testing we're doing is point of care biomarkers, which are pretty reasonably priced and something that could feasibly be integrated into this setting. Like I think the CRP testing we're doing is like $4 a test, and then there's a GloCal that's like $8, and so not ideal and more than is being spent per patient right now. But if that could eliminate tons of antibiotic use that's not necessary, like the future sequelae of antimicrobial resistance, etc., then it may be something to look into. But right now we just need to know a little bit more about that before we start to change guidelines and kind of shift what we do to differentiate these patients. So that was a long-winded answer, but
Could I just ask a quick question? For the children that you're identifying who are not identifying a viral etiology for the febrile illness, that's what triggers the evaluation, is a temperature. Is that basically how your algorithm is working?
are you saying like what our inclusion?
So who do you test for viruses?
So right now, we don't have the funding to test everyone with metagenomics. So currently, the only patients that are getting metagenomics is going to be the ones that have respiratory symptoms, but we are banking samples of plasma from everybody with the hope that eventually we can also do metagenomics on the plasma to see if there's signs of bacterial pathogens in there, because we also know that blood cultures are not perfect, and especially in this setting where there's lots of pre-treatment, like people can go, like Gama showed you, kind of this is a pluralistic health system, so there's lots of pre-treatment, etc. So picking up metagenomics may be a better option to pick up some of these pathogens that may not grow out on the culture, that kind of stuff. But that's the next step, I think.
Any data that you are collecting that could inform the antimicrobial resistance agenda, which is well funded globally, would be smart to think about. Who are you identifying? Are you identifying individuals who are on antibiotics and actually had potential resistance development, or is this a group that really isn't that kind of a threat? But there's eager money available for that kind of research. So
yeah, and Gama can speak more about it with his phage work, but he's planning on taking whatever we grow out in cultures and doing more of that. We just invested a bunch more. Like that wasn't our original intention. We were going to do the bare minimum on the micro side, but now we've actually kind of stepped up our game a little bit to be able to test for resistance and all of that, so that hopefully we can have that information, because I agree it is hugely important, and there's also money behind that as well. So
and I think we're at time now, so I think if there's any other questions, if you guys want to come up and ask in person, or also feel free to email, if you wouldn't mind to put your email on the board, is that okay? So I just want to say thank you very much. This was really
And just to make one last announcement, we hope you enjoyed your first IGHS day. If you have any suggestions, to Susan Shea, SAHSIEH, at ucsf.edu, please let her know. We're happy to accommodate all sorts of ideas. Thank you.